Hello, everyone. In the last lesson, we learned about the principles and basic operations of a coordinate measuring machine, CMM. Next, let's take a demo part as an example to learn the measurement steps using the CMM. The measurement steps of the CMM are mainly divided into the following parts: probe configuration and calibration, part clamping and alignment, coordinate system setup, feature measurement, dimension evaluation, and outputting the measurement report. In this lesson, we will first learn about probe configuration and calibration, part clamping and alignment, and course establishment of the coordinate system. By the end of this lesson, I hope you will be able to independently complete probe configuration and calibration for an injection molding demo part, master the basic principles and steps for part clamping, as well as the methods and techniques for alignment, ensuring the part is positioned correctly during the measurement process. Now, let's start with the first part, probe configuration and calibration. The first step is to analyze the part to be inspected, familiarize yourself with the inspection content, and list the measurement dimension table. By observing the drawing, we can see that reference points A, B, C, and D are clearly specified. Based on the principle of reference overlap, when establishing the coordinate system, priority should be given to using these reference points for alignment. After carefully reviewing the drawing, we organize the 12 measurement dimensions, associated features, nominal values, and tolerances into a table. The second step is measurement preparation. First is the probe selection. This is based on the laboratory's existing equipment and the required measurement feature size range. Here, based on the distribution of features on both sides of the part and the required measurement range, we know from the drawing that the optical reference hole depth of the part is 35 mm, and the smallest hole diameter to be measured is 10 mm. Therefore, we choose a probe with a diameter of 3 mm and a length of 4 mm. Based on the distribution of measurement features, 3 probe angles are added: A0B0, A45B90, and A90B180. Next, let's move on to the second part clamping and alignment. When clamping the part, 2 main factors should be considered. 1. Minimize the number of clamping operations to ensure that all features can be measured in a single clamping. 2. Ensure the part fits within the measuring range of the CMM and is placed in the center of the CMM's measuring platform. The long side of the part should be parallel to the x-axis, and the short side should be parallel to the y-axis. For this project, we use hexagon flexible fixtures to clamp the part. The clamping steps are as follows. 1. Use 2 screws to secure the base. 2. Mount the part on the base, securing and leveling it. 3. Complete the part clamping, as shown in the image. After the part is clamped, alignment is necessary. It is difficult to ensure that the part is perfectly aligned, both horizontally and vertically, in a single clamping with conventional fixtures. There is likely to be some degree of tilt or misalignment. Before measurement, it is important to ensure that the part maintains a perpendicular and parallel relationship with the coordinate axis of the CMM machine. The operation method is similar to the dial indicator alignment used in machining. The primary purpose of part alignment is to avoid probe interference with the part during measurement, which could cause probe collisions. If the part is not flat, probe interference with the part during measurement can easily lead to measurement errors. Now let's look at the actual operation. 1. Create a new measurement program, name it student number 3, set the units to millimeters, and click OK to enter the program editing interface. 2. Program parameter settings. Press F5 on the keyboard to enter the settings menu. Check display absolute speed, and set the maximum speed to 100 mm per second. In the dimension section, check show negative tolerance and choose 4 decimal places, which means data will be displayed with 4 decimal places. Click OK. Press F10 on the keyboard to enter the parameter settings menu. Set the approach distance and retract distance to 2 mm. The probing distance to 5 mm, the probe ratio to 1, and the movement speed to 100 mm per second. Select nominal values, tolerances, measured values, deviations, and out of tolerance. Click OK. Position the cursor on the probe loading location. Press F9 on the keyboard to enter the probe editing interface. Sequentially select the probe seat, probe, adapter, and CMM model. Then click to add an angle. Add 3 probe angles, A0B0, A45B90, and A90B180. Probe calibration can be done according to the previous task instructions. The final results should appear as shown in the image. Click OK, and then view measurement results. The measurement error for each angle should be less than 0.002. If the error is not less than 0.002, repeat the calibration or replace the probe until the error for each angle is less than 0.002. Next, align the part. In the program, call the probe A0B0 and touch 2 points of equal height on reference surface B, which will give measurement commands for point 1 and point 2. Compare the measured x coordinates of the 2 points. If the absolute difference is greater than 0.1 mm, the part position needs to be adjusted and measured again. As shown in the image, compare the measured y coordinates of the 2 features. If the absolute difference is greater than 0.1 mm, adjust the part position and measure again until the absolute difference is less than 0.1 mm, which indicates that the part is aligned correctly. Through today's lesson, we have learned the measurement steps for the injection molding demo part, including probe configuration and calibration, part clamping and alignment, and course setup of the coordinate system. We have understood the importance of probe selection and calibration, mastered the basic principles and steps for clamping the part, as well as the methods and techniques for alignment. I hope everyone can apply the knowledge learned today to actual measurements, continuously improving your measurement skills and precision. Finally, please reflect on this lesson and complete the following exercises to consolidate the knowledge you learned today and deepen your understanding. This lesson ends here. See you in the next lesson.